All right, so 9.5 is on angles of elevation and depression. These are all real-world type examples, but they can be somewhat confusing, just kind of depending on how they're worded and getting you're going to be drawing triangles, but getting them labeled correctly can be kind of confusing. So an angle of elevation, that's like when you're looking up, elevating, you're elevating up. So you're looking up, you have an angle of elevation. And so you always start by thinking, okay, if this person was looking straight ahead, okay, where would their eyes be looking? And you draw a horizontal line. You think, okay, here's their eyesight, horizontal line. If laser beams were shooting out of their eyeballs and they were looking straight ahead, where would that be? And then assume they look up at something. And so your angle of elevation is that angle that's kind of between those two lines. But you always have to think about that horizontal first line, and then they look up. So I've kind of put some little images here so you didn't have to draw them, because it helps to think about it. So Jeff sights the top of an 84-foot tall lighthouse. All right, so think about if Jeff was looking straight ahead. This is the first part, if he was looking straight ahead. Now that lighthouse is 84 feet tall. So this lighthouse, the whole thing is 84 feet. And so he looks up at an angle of elevation. So he looks up to the top of the lighthouse of 58 degrees. And we know that Jeff is 6 feet tall. All those are kind of important. We want to know how far he's standing from the base of the lighthouse. So we want to know this distance. Now, in trig, if we're finding one of the sides, we have to know at least an angle and at least a side measure. So we've got to know another side. We can find that vertical length. We take 84 minus his height of 6. That's going to give us 78. Then I'm just going to kind of draw this triangle with. So it is difficult. You have to be able to correctly label your angles and sides. And it's not always a straightforward, you just kind of have to read it and kind of think through some of the measurements that you're given to figure out what goes where. So in this triangle, you always start by labeling your H. So there's my 90. My H would be over here. Your opposite side is across from the angle, so over here where the 78 is. And then your adjacent is the other one, so there where X is. So we have something at O and A. Which trig function uses O and A?
Teacher, sorry about the delay. You go ahead and post it.
What is it? Tangent. So tangent of our angle, 58. You always put your angle with your trig function, equals O over A. So 78 over X. All right. And then we put a 1 there and we cross multiply. So 78 times 1 is 78 equals X tangent of 58. And to get x by itself, we have to divide both sides by tangent of 58. And you should get 48.7 feet. Number 2. The angle of elevation from a kicker's foot on the football field to the top of the goalpost bars is 17 degrees. So you got to think about, here's his foot. If there was a horizontal line, that's kind of where we start. And then the angle of elevation is up. And that's 17 degrees. If he is standing 131 feet from the base of the goalpost, so that would be down there. Another stupid ant. I don't know. Does anybody see any ants anywhere else? Like, they just keep showing up on my desk, and I don't know where they're coming from. Okay. Oh, no, I lost that one. So I keep spraying them and killing them. All right, so we want to know how tall is the goalpost. So really, we're finding this length right there. This picture, really, I guess his feet are really still standing on the ground. We should have drawn from his foot. Because, when he goes to kick it, he kicks it from the ground. All right, so you don't have to redraw these, but. All right, so if we label the 3 sides, this would be H, O, and A. And so we're using tangent again. So we didn't get to use tangent much in our bingo game, so now you're getting it. Tangent of 17 equals x over 131. So then if we put a 1 under there and we cross multiply, we get x equals 40.1 feet. Any questions? All right, number 3. Oh, come on. All right. Number 3, Leah's mom is standing at the bottom of the slide. Let's see. Waiting for Leah to slide down. So her mom, okay, obviously if she was standing, she would be probably eye level, but so the angle of elevation from the bottom of the slide up is 46 degrees. So basically if she's here and she would look straight ahead and then she looks up, 46 degrees. The slide has a vertical height. Oh, I don't think I drew that right. Sorry. Okay. Leah's mom does not have anything to do with this. So it's asking the length of the slide, really. So it's asking for that length. And so here's your horizontal line. It's kind of hard to see. So your horizontal line is right here. And then looking up is 46 degrees. the slide is 9 feet tall, we want to know the length of it. So basically, this is our triangle. Right there. All right, so if we label, we have our H. Across from the 46 is my O, and the other one is A. This one uses O and H, so that is sine. Sine of 46 is 9 over X. And then if we put a 1 under here, we can cross multiply. So 9 times 1 is 9, and then X sine of 46. And then we divide both sides. We got to get X by itself, so we divide both sides by sine of 46. So X equals 12.5 feet. Number 4. A dog is standing 5 feet from the base of a tree. Okay. So 5 feet, looking up at a cat that has climbed 16 feet up in the tree. My triangle is very not drawn to scale. What is the angle of elevation from the point the dog is standing on the ground to the cat? So really, that's a more accurate triangle. So what is the angle of elevation? So that's where our X would be. So across from the 90 is H, my hypotenuse. Across from my angle X is O, and the other one is A. This one uses tangent because O and A. So tangent of X equals 16 over 5. And if you remember when we learned about the angles last week, to get X out, we have to do tangent inverse of 16 over 5. That's where you hit second tangent, and then you type 16 divided by 5. And you get 72.6 degrees. Any questions? All right. So angles of depression are very similar, except you're looking down at something. So you have a horizontal line, and then you're looking down. It's the only difference. So if we look at some examples, and hopefully you can see that's kind of dark here. Stupid ants. Kill them. People watching this video are probably like, what in the world's going on? I sprayed that one and it like slung it. He's dead. All right. So lifeguard is sitting on a platform looking down at a swimmer. So here is his horizontal line, and he looks down at a swimmer. All right, so if his line of sight, that horizontal line, is 8 feet above the ground, and an angle of depression, and the angle of depression is 18 degrees, how far away is the swimmer from the lifeguard? And assuming that when it's talking about this distance, and I'll try if there's, I don't even know if there's any of these on the final, but sometimes it's not obvious. Okay, is it talking about if he were to jump from there, or is it talking about this horizontal distance? So if the lifeguard were to get down on the ground, how far away would he be? That would be the horizontal line. That's what it's asking here. I will try to make them obvious. Which one it is. Okay. Eight x 18. All right, so across from the 90 is h. Then we have this 8, that's my opposite because it's across from the 18 degrees. My other one is the adjacent. So this one uses tangent. A lot of these do use tangent, like just the way the scenarios work out. Tangent of 18 equals 8 over x. So we get 8 equals x tangent of 18. So we have to divide. To get x by itself, we have to divide. So x equals 24.6 feet. Number 6, a pilot in a helicopter spots a landing pad below if the angle of depression is 73 degrees. All right, so here's that horizontal line, and there would be looking down, so your angle of depression is 73 degrees. The horizontal distance to the pad is 1,200 feet, so we know it's talking about that. What is the altitude of the helicopter? That's kind of the height of it, so the vertical distance. So across the 90, that's your H. Across from the 73 is your O. The other one is the adjacent. So this uses tangent again. Tangent of 73 is x over 1,200. When you cross multiply, you multiply them. When the x is on top, that's when you multiply them. The x is on the bottom, you divide. And we get 3,925 feet. Number 7, building A is 480, feet tall. So let's see, 480. Building B is 654 feet. The angle of depression from the top of building B to the top of building A is 42 degrees. So basically somebody's sitting on the top of the building looking down. So if got your horizontal line first and then you're looking down is 42 degrees. We want to know how far apart the buildings are, and that would be a horizontal distance. We can find this vertical height of the triangle. We just subtract the two. So 654 minus 480 is going to give us that part of the triangle, which is 174. So we got our H, O, and A. Guess what? It's tangent again. Oh my gosh. All right. So tangent of 42 is 174 over x. So you get 174 equals x tangent of 42, and then you have to divide. X equals 193.2 feet. Any questions? Zach is standing at the top of a lookout tower and spots a water fountain below. Okay, so here he's in there. So here's his horizontal line, and then he looks down. If the lookout tower is 75 feet tall, okay, so this is 75. That water fountain, I guess, should have been a lot shorter. The angle of depression is 28 degrees. What is the horizontal distance between Zach and the water fountain? So I guess if he were to climb down, straight down, how far would he have to walk to get to it? So set that one up. Nasty. Find an ant. Like, I don't know. Like, I've looked in the windows. Like, I don't know where they're just randomly separated out. I don't know. All right, so you should have got 141.1